Hi, welcome to the first video of Rust programming language tutorials. Now, in this first lecture, I want you to look at this line of code, and you may ask, what does U32 mean, and what are these type declaration? So before really diving into that, first we need to know what are bits and bytes. Before knowing what bits and bytes are, I want you to know this. So electronic systems fall into two categories: the analog system and the digital system. The analog system use the current, the wave, to represent data, and the digital system use pulses to encode data. So the communication between two systems using a stream of zeros and ones like this. So each piece of information, either 0 or 1, is called a bit. Now we can store bits in memory such as RAM or SSD, or we can even transmit them. Now let's pretend this is an SSD, a solid state drive in a computer, right? So it stores only 1 and 0. So this little box right here, a little purple box right here, is a bit. So a bit is the smallest piece of data in a digital system. So it can be either 0 or 1, or it can store anything that has only two options, like true or false, and so on and so forth. However, there is a problem. A single bit like this is not enough to encode a number such as 123 or a piece of text such as hello. So to make working with bits easier, we put several of them together like this. Okay, now a single bit can only encode two states, 1 or 0. So if we put two bits together, the machine can decode 4 states, like 0, 1, 1, 0, 0, 0, or 1, 1. So generally speaking, n bits allows us to encode two power of n states, and this allows us to represent whole more numbers. So while n bits allows us to encode 2 power of n states, and the most common of n is 8, which allows us to encode 2 power of 8 states equal to 256 states, and this data type is called byte. So it was not bit, but it's byte is the smallest addressable unit of memory in many computer architecture. So how we can use a single byte? So I have a little example here. 8 bits represent 1 byte that you can store up to 256 states. Now how can you use this single byte right here? Now you can store a number, right, a person's age, or we can store every single symbol in a Latin-based alphabet, and this includes small and capital letters, numerals, punctuation, or even accent variation, and so on. However, there is a problem. This 1 byte is not big enough to represent many other alphabets like Chinese or Japanese, and leave no encode characters such as pictogram or smileys or emojis, and etc. There is another problem, is that a single byte is quite restrictive because it only decodes 256 possible states. What happens if we put 2 bytes together? What happens if we ask the computer to give you 2 bytes to store? So if we put 2 bytes together, now you're going to have 2 power of 16 states equal to 65,536 states. Now you can store even larger numbers. Alright, so let's get back to our first picture of the lecture. Now, when you declare U32 as a type, it means that you are asking the computer to give you 32 bits of storage to store a number inside these 32 bits of storage. Alright, that's the first video, and in the next lecture we're going to talk about signed and unsigned variables.